Okay, let's have some fun and multiply some monomial expressions. Remember, the word mono means one. I have one term here, I have one term here. Now this is arithmetic, it's algebra. Just to reiterate, to multiply -8 times -7, there is no work to do on paper. It's all up here. First thing, our rules. A negative times a negative is always going to be a positive. Always. Don't question it, don't think about it, just know your facts. So we know this is going to be a positive. And 8 times 7 is on your times tables, that should be 56. When you multiply a monomial times a monomial, your answer is one term a monomial. Okay, let's do some algebra now. -5c squared times -4d times -e cubed. First thing we do is we multiply the coefficients. These are all monomials. Because we're connected by multiplication, we could change the order. So it only makes sense to multiply numbers times numbers. So our coefficients are -5, -4, and the coefficient here is a -1. That's what we're multiplying first in our head. -5 times -4. A negative times a negative is a positive. So that would make positive 20. But positive 20 times -1. A positive times a negative is a negative. When you multiply different signs, your answer is negative. So positive 20 times -1 would be -20. Okay, we multiplied all the coefficients. I don't need to see a stitch at work. I know you did it here in your head. Now we're going to multiply the variables. The rule is when you multiply letters, you add exponents, as long as the bottoms, the letters, the bases are the same. This base is C, this base is D, this base is E. They are not the same. So there's no adding exponents. So the way you show you're multiplying a C to a D to an E is you just write those letters in alphabetical order. So we would write, I have a C squared, I have a D, and I have an E cubed. If you look, my answer, my product is all connected by multiplication. Everybody's side by side kissing each other. There's nothing in between the letters and the numbers. Therefore, this is a monomial. A monomial times a monomial will always be a monomial as your answer, your product. Okay, again, no work, all up here. Let's try one more. Let's try with fractions. I know you guys don't like fractions, but we're going to have a lot of fractions in algebra. Got to get over it. Again, everything here is a monomial. It's all connected by multiplication. Everything in here, this whole term is a monomial, connected by multiplication. So the rule is to multiply monomials, we first start with the numbers, the coefficients. So we're going to multiply 2/5 times -15/10. Before I multiply, I'm going to think, this fraction's positive, this fraction's negative. What's a positive times a negative, y'all? It's a negative. Now we're going to multiply fractions. Top times top, bottom times bottom. 2 times 15 is 30. Bottom times bottom. 5 times 10 is 50. Now we're going to multiply the variables. We're going to find the same base letter, and then we can add exponents. So if this is m to the 4th, we can multiply to m squared, and 4 plus 2 means I have m to the 6th. I have an n, and this is also base n. So I know with this letter n, there's an invisible exponent of 1. 1 plus 5 would make n to the 6th. Now the problem in algebra is all answers have to be in lowest terms, reduced, simplified, whatever word you want to use there, they all mean the same thing. The first thing you know is fractions have to be in lowest terms. What can we divide 30 and 50 by? You're right, 30 and 50 are both even, they can divide by 2. 30 and 50 can both divide by 5. But when we're reducing fractions, we're always looking for the greatest common factor, the biggest number they have in common. If they both end in a digit 0, we can divide by 10. So 30 divided by 10 is 3. 50 divided by 10 is 5. So now we have -3/5, and we have the m to the 6th and the n to the 6th. And if you look, you can write your product your answer like this, with the negative in the middle of the bar and the variables in the middle of the bar. That's one way to write the answer. Another way that's acceptable to write this answer, which is the way I prefer as a math teacher, is to place everybody accordingly. I don't like terms hanging in the middle of a fraction bar. So guys, whether it be a number or a letter, if you have a fraction and there are terms in the middle of that bar, they rise to the top. So I would rewrite this as saying this is -3, the negative floats to the top, and the variables m to the 6th and n to the 6th float to the top. And that would leave in the denominator a 5. And that means the same thing. This expression and this expression are equivalent. They mean the same thing. It's just a preference on what your instructor would rather you write it as. So pay attention. One more little nitpicky thing I want to bring up now that I can. A lot of you are probably saying, Miss Black, why are you multiplying top times top and bottom times bottom? Why don't you reduce first or divide? You can do that. So just if I take those fractions, 2/5, and I take the 15 over 10. A lot of you know the trick to that. And the trick to that is, before you multiply going top times top and bottom times bottom, these bars mean to do division. And you can reduce divide first. You guys call that cross-canceling. And I'm cool with that. You can do that. I agree. 5 can divide into 15. How many times? 3. So you'd say 15 divided by 5 is 3. 5 divided by 5 is 1. You can cross-cancel 2 and 10 because you can divide both of them by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. And now if you do your multiplying, 1 times 3, you get 3. And 1 times 5, and you get 5. Now, the important thing is understanding why does that work. Because if you look, this means multiply. These bars mean to divide. And if you go back to, please excuse my dear Aunt Sally, multiplication and division are equal. Mom is not better than dad. Dad is not better than mom, which means it doesn't matter what order you read it in. So if you want to do the division first by reducing, that's great. If you want to do the multiplying first, that's great. Either way, we're going to get the same fraction, 3/5.